So if I pick a point in space, and I'll draw a picture, let me reread this all the way from the beginning so it's not so choppy. Postulate number 1, sometimes referred to as the ruler postulate, and you'll see why in a second when I draw my picture. Says that every point on a line can be paired with a real number. So I got a point on a line, I can assign a numeric value to it. And it can be paired with a real number. This makes a one-to-one correspondence between the points on the line of real numbers. Okay? The real number that corresponds to a point is called the coordinate of a point. What do I mean by that? The numerical value of b is 5. I can't assign 0 to b and 5 to a. So 1-to-1 means whatever number I assign to a, that's it. There's one number for one point. 1-to-1. Same goes for b. 1 point, one number. 1-to-1 correspondence. Now the numerical value of that is the coordinate. So we could say that a, if this was a number line, if I drew a number line like this, we could say that a had the value of 0 and 5, and b had the 0 of 5. So the coordinate for a is 0. And the coordinate for b is 5. Now when we graph things, we talk about the x, y plane. That's really just two number lines, isn't it? One going horizontally, the other one going vertically. By the way, if I had a point here that had x comma y, we would say that this is the x coordinate and this is the y coordinate. And the x comma y is the ordered pair. That gives us a location for a point in time and space. Well, in space, in two-dimensional space. I'm getting a little ahead of myself. Does that make sense to you guys? Okay, so that's the postulate. All right, now let's move on to the example. So now for example number 1, we have a drawing here. And this drawing has a number line. And on the number line, we have over here at -4. A little bit further down, we have 0. A little bit further down, we have 8. And this isn't drawn to scale. And then we have 10. And then we have 14. And as I said, I'm not drawing it to scale. This point right here is S. This point right here is T. This is U. And this is V. And so for example number 1 in your textbook, what they want us to do is identify what is ST. What are they asking us? What's the distance from S to T? Right? Well, we have to identify something. So we're going to say that S has a numerical value, or the coordinate of -4. T has a value of 8. How do we find the distance? Well, yep, go ahead. Well, they suggest that you do the absolute value of the difference. What's S? -4. What's T? 8. I'm going to write it this way so you can see what we're doing. I'm going to show you a little trick too. So what is -4 minus 8? -12. What's the absolute value of -12? 12. So this thing equals 12. Now we can verify this. We know that we would go 1, 2, 3, 4. And here we would go 1, 2, 3, 4, 5, 6, 7, 8. So here we have a distance of 8. Here we have a distance, if you add those up, it's 12. Let's try this another way. ST is equal to the absolute value of the difference let's switch them around. Let's say t, which is 8, minus, what's the value for s? -4. What happens when we minus a minus?
You add it.
Yeah, so what's this end up becoming? 12. What's the absolute value of 12? 12. Hey, that's no accident. Alright? Cool. So then the absolute value of this thing is 12. Alright, now the textbook asks us a couple other things, like, what about UV? What's that? 14 minus 10 is 4. Alright, what about TU? 2. What about TV?
6.
6. Any questions on that? Does that make sense?